Okay, so now we look at this module on correlation analysis. So the correlation analysis could be used to quantify the nature of the relationship between two node level metrics in a social network. Okay, so for example, you can say social network of say some people where you're given the weight and height of the users in that network. So with correlation analysis, we can quantify the extent to which the ranking of the users, say for example, based on the weight, is the same as the ranking of the users based on the height. So how close is the ranking? So we can quantify the similarity in the ranking based on the two different metrics. Also, we can say kind of like pairwise similarity. So if say for two users A and B, if the weight of A is greater than the weight of B, can we say the height of A is also greater than the height of B? Okay. With correlation analysis, we can also say or do some prediction of say one metric using the values of the other metric. So for example, you can do the prediction of the user height based on the values of the user weight, and you can also say how close is this to the real value. Okay. Alright, so we are going to basically look at three types of correlation. One is kind of the rank based correlation, and the other is the concordance based correlation, and then we are looking at the Pearson's correlation. This is a linear correlation, so we'll see the details as we proceed. Okay, so the rank based correlation, as the name itself indicates, is going to compare or quantify how similar are the ranking of say the vertices with respect to two different metrics. Okay, so here you are given a social network of say 7 users. So we'll try to understand this correlation analysis using this example. So given say a social network of 7 users and their weight and height, and these are absolute values, absolute weight value in pound and the height value in inch. Alright, so what we're going to find is find a correlation coefficient based on the ranking of the users with respect to these two metrics. Okay, so we can write down the first element in the tuple is the weight and the second one is the height, and we can write down these as a column for the different vertices 1 through 7. So that's what I have also written here, and now we can rank the users, the vertices based on their say weight. And what we'll come up with first is what is called a tentative ranking, and we'll see the purpose of it is to to handle the ties, and we'll soon see that. Okay, so the tentative ranking, again we have to follow a convention in the sense that do we give so we give the rank numbers 1, 2, 3 and so on. So we have to fix something. So do we give a lower value, a lower rank number, or a lower value will get a higher rank number? So in this example, we'll follow the convention that the lower value will get a lower rank number. So the lowest among these high weight values is 125, so that is rank 1. Okay, and then the next lowest value is 130, that is rank 2, and then you have 135, that's rank 3, and then 150, that's rank 4, 163 rank 5, 178 rank 6. Let me make it a little bigger. Okay, so the lower rank weight value will get the lower tentative rank. So 125 will get rank 1, then 130 will get rank 2, 135 rank 3, 150 rank 4, then 163 rank 5, 178 rank 6, 185 rank 7. Now in the case of weight, we did not observe any tie in the sense two or more vertices having the same weight. So every vertex had a unique weight, so there was no tie. So in that case, the final rank will be the same as the tentative rank. Okay, So we'll just copy the values, rank values for tentative rank, also for final rank. Now the height values of the users are given here. Now the lowest among this is 55. Now there are two users with a height of 55. So this is where we have a tie. So for the tentative rank, we still give them a unique rank number. So if two users or two or more users have a tie, we break the tie based on the node ID or the vertex ID. So vertex 1 will get the lower rank number and vertex 3 will get the higher rank number. So that is 1 for vertex 1 and 2 for vertex 3. So we want a unique tentative rank values. Then the next smallest height is 60. That's only one here. So tentative rank of 3, then 68, 4, then 74, 5, 75, which is different from 74, so there's no tie, so it is 6, then 85 is 7. So once you get the tentative rank, we need to find the final rank. Now in this case, you see that we had a tie with 55 and we gave the tentative rank of 1 and 2. So the final rank for all the vertices that have a tie is going to be the average of the tentative rank values. So the tentative rank values we had were 1 and 2. So it's going to be 1 plus 2, which is 3 divided by 2. So it's average of 1 and 2. So average of 1 and 2 is 1.5. So that's going to be the final rank for both vertices 1 and 3, 1.5. Then we have 3. So 60, there was no tie, so final rank is same as tentative rank. Then 4, 5, 6 and 7. So once you get the final rank values for the two metrics, height and weight, we'll find the rank difference. So basically compute the difference in the final rank values. So 2 minus 1.5 is 0.5. 4 minus 6 is negative 2. 1 minus 1.5 is negative 0.5. 6 minus 5 is 1. 7 minus 7 is 0. 5 minus 4 is 1. 3 minus 3 is 0. So once you get the final rank difference, you can square these differences. So 0.5 square is 0.25, negative 2 square is 4, negative 0.5 square is 0.25, 1 square is 1 and so on. Then the sum of these squares of the differences. So sum of all these squares of the differences comes out to be 6.5. And now we have a formula in which we can plug in these numbers. So we have the sum of the squares of the differences as 6.5. So it's going to be 1 minus 6 times 6.5 divided by, it's a graph of 7 vertices, so 7 times 7 square minus 1. So that comes out to be 0.8839. So the rank correlation coefficient will be in a range of 0 to 1. And closer it is to 1, we can say the ranking of the vertices with respect to the two different metrics is going to be similar. So with respect to height and weight, we can see the ranking is like 2, 4, 1, 6, 7, 5, 3, the final ranking. Here you have 1.56 and so on. So comparing the numbers could give you a feel of how close are the rankings, and the differences could also tell you that. Okay. So that is the Spearman's rank-based correlation coefficient. So let me stop the video with this.